It was a fever dream forged in steel, a 200-ton armored behemoth born from the desperation of a failing war. Imagine a land dreadnought the size of a two-story house, weighing as much as 10 medium tanks combined. Its hide was engineered to be so thick, so utterly impenetrable, that no anti-tank gun of the era could hope to leave a scrap. This colossus was meant to be the decisive weapon, the key to breaking the stalemate on the Eastern Front and carving a path to Moscow. Its creation was approved by Adolf Hitler himself, who demanded its mass production begin with the utmost urgency. But this machine carried within its gargantuan frame a single fatal flaw. It was simply too heavy for its own world. By the spring of 1942, the war for Germany was spiraling out of control. The Blitzkrieg, a tactic of lightning warfare that had shattered Poland and France, had bogged down in the vast, unforgiving expanses of the Soviet Union. German panzer divisions, once thought invincible, were now swallowed by Russian mud and crippled by Siberian frosts. The Soviet T-34 and KV tanks proved to be far more resilient adversaries than German strategists had ever anticipated. Hitler was enraged. He needed a miracle weapon, a technological specter to restore German initiative. He summoned representatives from the Reich's largest engineering firms and presented them with a task many considered insane. He demanded a tank that would be absolutely invulnerable. Its armor, he insisted, must be so thick that Soviet shells would simply not even return fire. Size and weight, he declared, were irrelevant. This was to be a machine of absolute, unquestionable superiority. The contract was awarded to Porsche, a company already famed for its engineering prowess. Ferdinand Porsche, the firm's founder, was a personal favorite of the Führer and enjoyed his complete confidence. The initial technical brief called for a 100-ton tank, a specification that was already pure fantasy. The heaviest German tanks of the time weighed no more than 57 tons. But Porsche's engineers, driven by ambition, decided to go even further. When the final blueprints were laid on Hitler's table, even he was momentarily stunned. Before him was the documentation for a 200-ton fighting vehicle. The frontal armor was 25 centimeters thick, more than the armor on many contemporary warships. Its flanks were shielded by 18-centimeter plates of hardened steel. Even the roof boasted 6 centimeters of armor, making it impervious to small-caliber aircraft bombs. Within its turret, a 128mm cannon was planned, a gun capable of piercing any existing tank from over 2 kilometers away. Hitler was ecstatic. He saw visions of these steel monsters plowing through Soviet lines, impervious and unstoppable. It was the perfect physical manifestation of his ideology of overwhelming force. Yet, in the pursuit of invincibility, they had created a paradox. A weapon so mighty, it could barely move. A fortress chained to the very ground it was meant to conquer. It stands not as a monument to power, but as a testament to the profound arrogance of believing that sheer mass can ever overcome the fundamental laws of reality. It was a vision of absolute power. A rolling fortress designed to carve a path through the heart of the Soviet defenses, sweeping away everything in its path. No anti-tank gun would halt its advance. No minefield could breach its armored belly. It would move slowly, yes, but with the crushing inevitability of a glacier, turning enemy fortifications into little more than piles of rubble. The Führer, captivated by the sheer audacity of the concept, approved the project immediately, demanding a prototype be constructed in the shortest possible time. The project was given a code name intended to reflect its might, its unstoppable nature. But the engineers, With a gallows humor that only men facing an impossible task can muster, christened this Leviathan something else entirely. They called it the Maus. The Maus. A feverish period of work began. The chief, soul-crushing headache for the designers was its heart. To move 200 tons of Krupp steel required a power plant of monstrous proportions. They first turned to the skies, attempting to adapt the colossal Daimler-Benz MB-509 aircraft engine, a massive 12-cylinder unit normally found in heavy bombers. But even this powerful motor could not cope. The tank either refused to move at all or crawled forward at the pathetic pace of a walking man. So, they went bigger. They installed an even more powerful diesel engine, the Daimler-Benz MB-517. This new monster could develop 1,200 horsepower, but it was so vast that, together with its electric generator, it consumed a staggering 2/3 of the hull's entire internal volume. What remained was a cramped, unforgiving cell for the 5-man crew. The commander, gunner, loader, driver, and radioman were to be sealed inside, with only a few square meters of space to share. By May of 1943, a full-scale wooden mock-up was finally ready for Hitler's inspection. He arrived at the secret proving grounds and circled the giant structure several times, his gaze tracing its colossal lines. It stood over 3.5 meters tall. Its length exceeded 10 meters, its width nearly 4. This was not a weapon. It was a true terrestrial monster. After demanding a few minor changes, Hitler signed the order on the spot. 150 machines were to enter full production. The war would have its wonder weapon. But while the Führer dreamt of victorious mouse parades through Red Square, his engineers were colliding with a reality that was far less glorious. The first running prototype was ready by the end of 1943, and it was then that the true trial began. As the 200-ton behemoth first roared to life, its diesel heart shuddering through the very ground, the assembled military officers and designers held their breath. It lurched forward across the concrete testing yard, and then, after only a few meters, a sickening cracking sound began to echo under its tracks. The concrete surface, engineered to withstand the movement of any ordinary heavy vehicle, was simply shattering under the incredible, focused mass of the Maus. Each track left a deep furrow in its wake, a permanent scar several centimeters deep. The road buckled and broke, deforming as if a herd of elephants, not a single tank, had passed. It was a machine so heavy, so powerful, it destroyed the very ground it needed to cross. The weapon's greatest enemy, it turned out, was not the Red Army, but the unyielding laws of physics themselves. It became brutally, undeniably clear that not a single existing road in Germany could withstand the passage of this colossus. The very infrastructure of the nation it was meant to defend would crumble beneath its weight. And yet, the plan called for the production of 150 such machines, and some method of deploying them to the front lines. The reality, however, was far more humbling. When trials moved from paved surfaces to open country, the situation deteriorated from problematic to catastrophic. On soft ground, the Maus's enormous tracks sank a full half-meter into the earth. The tank ceased to be a vehicle and became a gargantuan plow, literally carving the landscape as it moved, leaving behind deep, impassable trenches. It wasn't just fighting the enemy, it was fighting the planet itself. At the slightest incline, the overstressed engine would begin to overheat, its temperature gauges climbing into the red, while its forward momentum dropped to the speed of a crawling snail. The driver mechanic's reports were a litany of despair. He noted that controlling the behemoth was an almost superhuman task. The slightest turn of the tiller demanded immense physical effort, a battle of man against his own mechanical creation. Its braking distance stretched for tens of meters, turning any attempt at a sudden stop into a controlled, earth-shattering crash. If the brakes were applied too sharply, the tank's own monumental inertia would cause it to lurch forward, its nose digging violently into the ground under its own impossible mass. The absolute maximum speed they could coax from the prototype was a mere 20 kilometers per hour, and that was only achievable on a perfectly flat, solid surface. By comparison, the Soviet T-34 could reach 55 kilometers per hour. The German Tiger, a formidable machine in its own right, could manage 45. The grim calculus was simple. Any enemy tank could simply drive away from the Maus, shelling it from a safe distance with impunity. Even marching infantry moved faster than this steel giant. The grand vision of a swift, decisive breakthrough, spearheaded by an invincible fortress, had dissolved into dust. But the true nightmare began when they attempted to guide the Maus across a river. German combat engineers, anticipating the challenge, had heavily reinforced a bridge, calculating the load with a massive margin for error. As the tank began its slow, ponderous crawl onto the structure, a deep, ominous groaning echoed from the steel and concrete. Halfway across, the support beams visibly bowed. Cracks spiderwebbed across the bridge's surface. The crew commander, seeing the disaster unfolding beneath him, screamed the order to immediately reverse. The bridge held, just barely, but an inspection revealed it was structurally compromised, unfit for any further use. It was sent for a complete overhaul. The lesson was learned in the most terrifying way possible. No existing bridge in Europe could bear the weight of this monster. Engineers scrambled, desperately seeking a solution. One proposal suggested building specially fortified bridges ahead of the tank's every advance, which meant the Maus would move at the glacial pace of a construction crew. Another idea, even more far-fetched, was to transport the tank in pieces and assemble its 200-ton bulk in the field, a logistical absurdity. Then, from the designers at Porsche, came a source under them. It would ford them on net. Every hatch was fitted with heavy rubber seals, and rising from the turret was an 8-meter telescopic tube, a schnorkel. Through this slender lifeline, air would be drawn in for the ravenous engine and for the crew, entombed in their steel shell deep beneath the dark water. The exhaust fumes, vented through specialized valves, were designed to function under the immense pressure of water. But even here, a fundamental problem emerged. Submerged, the Maus's engine could not generate sufficient electricity to power its colossal tracks. The solution they devised was unusual. A second Maus was to remain on the riverbank, acting as a generator. It would feed electricity through a special armored cable, several tens of meters long, to the first tank as it crawled along the riverbed. The initial trial for this underwater crossing took place in a small river, only about 5 meters deep. The crew climbed inside the hermetically sealed machine with palpable apprehension. The prospect of becoming trapped at the bottom of a river inside a 200-ton steel coffin was a fate no one wished to contemplate. Slowly, the Maus slid into the water. Its snorkel pipe protruded, churning out the vital electrical current. To the astonishment of everyone present, the system worked. The tank vanished beneath the murky surface, crawled for nearly 100 meters, and then, dripping with river mud and algae, heaved itself onto the opposite bank. But the relief was short-lived. The engineers quickly calculated that to ford a serious water, laying such a cable under enemy fire would transform the operation into a suicidal mission. Furthermore, While one Maus was crossing, the second had to remain stationary on the bank, a completely defenseless, living power station. And what if more than 2 tanks needed to cross? Would they form a whole chain of machines, passing energy from one to the next? The absurdity of the situation was becoming painfully obvious. Then, another catastrophic problem came into focus: its operational range. The gigantic diesel engine devoured fuel with an incredible ferocity. Even with a full tank, the Maus could travel a mere 65 kilometers on a paved road. On cross-country terrain, that figure plummeted to just 40 kilometers. In practice, the tank could move for only 3 hours before it became an immobile pillbox. For comparison, a T-34 could cover 300 kilometers on a single fueling, and a Tiger 140. Supplying an entire armada of Maus tanks would have demanded the creation of an unprecedented logistics system, with constant refueling required every few hours of movement. General Heinz Guderian, the father of the German Blitzkrieg and Germany's greatest tank strategist, inspected the Maus during its trials. He called the project grandiose, but everyone understood that from his lips, the word was laced with a deep, cutting sarcasm. Guderian had always advocated for large numbers of medium tanks, fast, maneuverable weapons capable of delivering swift, decisive blows. The Maus was the complete antithesis of this philosophy. It was a slow, gluttonous, and unwieldy colossus that demanded an army of support personnel and a mountain of resources. By the dawn of 1944, it was clear that even if the Maus, by some miracle, ever reached a battlefield, it was a weapon system born not of strategic necessity, but of a profound and fatal misunderstanding of modern war. To deliver it to the front would be an epic undertaking in its own right. German railway engineers reportedly clutched their heads in disbelief when presented with the tank schematics and asked to calculate the feasibility of its transport. Not a single existing railway platform in the entire Reich could bear such a monstrous weight. 200 tons of steel, concentrated over an area of just a few dozen square meters, created a ground pressure capable of deforming solid steel rails and shattering the sleepers beneath them. A special platform had to be designed from scratch, a colossal flat car with a reinforced frame and 24 axles instead of the standard 4. But even this purpose-built behemoth could only traverse the main arterial lines, those laid with the strongest rails and reinforced concrete sleepers. On standard tracks, the common wooden sleepers would begin to crack and splinter under the immense load. After just a few kilometers, the train's speed was restricted to a crawl, a mere 15 kilometers per hour. Any attempt to go faster threatened an immediate and catastrophic derailment. A journey from the factory to the front lines, a distance other panzers could cover in days, would, for this Titan, stretch into weeks. Loading and unloading the Maus transformed into a multi-hour, high-stakes operation, demanding the use of the most powerful cranes and custom-built ramps. Such pristine, controlled conditions simply did not exist at the front. Military logisticians ran the numbers, and the results were sobering. To support the combat operations of even a single battalion of 10 Maus tanks would require the dedication of an entire separate railway branch, dozens of fuel tankers, hundreds of supply trucks, and a veritable army of technical personnel. And yet, Hitler dreamed of a fleet of 150 such machines. Meanwhile, beyond the sterile confines of the proving grounds, the situation on the fronts was changing with catastrophic speed. In February, the Battle of Stalingrad concluded with the complete and utter annihilation of the German Sixth Army. 300,000 soldiers were lost, captured, or killed. It was the Soviet Union's first truly decisive victory, and it irrevocably broke the momentum of the war. The Red Army surged forward, launching a relentless offensive across the entire Eastern Front. That summer, the earth trembled at the Battle of Kursk, the greatest tank engagement in human history. Here, the Germans unleashed their newest predators, the Tigers and Panthers, hoping to regain the initiative. But the Soviet tankers, though outmatched in individual machine quality, held the line and hurled the enemy back. By autumn, Soviet forces had crossed the mighty Dnieper River and liberated Kiev. The front line was no longer advancing. It was relentlessly rolling westward. Germany, the aggressor, had become the defender. The very nature of the war had shifted. The Wehrmacht no longer needed ponderous breakthrough tanks to smash static defenses. It needed fast, agile machines for rapid counterattacks, for plugging gaps, for staving off the endless tide of Soviet armor. In this new, fluid reality, the Maus, with its top speed of 20 kilometers per hour, was completely and utterly useless. By the time this steel colossus could lumber into position to face a threat, the nimble Soviet T-34s would have already punched through the line miles away. Back at the testing facility, engineers continued their work on a second prototype, desperately trying to eliminate at least some of the identified flaws. A more advanced engine cooling system was installed. The transmission was refined, the suspension reinforced. But the fundamental problems remained unsolvable. It was simply impossible to make 200 tons of steel move quickly without an engine of almost unimaginable power. An engine which did not exist, and which could never have fit within its hull. The Maus was a weapon designed for a war that was already over. A monument to a strategic vision blinded by sheer scale. A titan of iron born too late to a world that now belonged to the swift. The laws of physics, it turned out, were far stronger than the ambitions of one man. For the colossal tank known as the Maus, the dream was already dying. But in June of 1944, an event unfolded on the distant shores of France that would finally, irrevocably, bury any hope of its mass production. The Allies had landed in Normandy. The Second Front, so long dreaded in Berlin, was now a bloody reality. Germany, already locked in a titanic struggle in the east, was now forced to fight a war on two fronts, its resources stretched to the absolute breaking point. The great factories of the Ruhr worked themselves to exhaustion, churning out the conventional tools of war, Panthers, Messerschmitts, artillery pieces. But a more insidious crisis was strangling the war machine. Fuel. The nation's lifeblood was running out. Day and night, the drone of Allied bombers echoed over the Romanian oil fields at Ploiesti, turning the Reich's primary source of petroleum into a sea of fire and smoke. Every ton of steel, every single liter of fuel was now accounted for with a desperate, miserly precision. In this grim reality, to spend such colossal resources on experimental giants that could barely even move under their own power was not just a mistake, it was an unforgivable luxury. The voice of cold reason came from Albert Speer, the Reich's Minister of Armaments. He presented the Führer with a report, its pages filled with the stark, unforgiving calculus of industrial warfare. The cost of a single Maus, he explained, was equal to that of 5 battle-proven Panther tanks, or 8 of the workhorse Panzer IVs. The raw materials and man-hours required to build the planned 150 of these super-heavy tanks could instead produce more than 1,000 medium tanks, machines that could actually influence the course of the fighting. Speer insisted, pleaded for the program's termination, for all industrial capacity to be redirected to proven, practical designs. But Hitler resisted. In the deepening twilight of his Reich, he clung ever more tightly to the belief in a Wunderwaffe, a miracle weapon that would somehow reverse the tide. The autumn of 1944 brought only more disasters. The Red Army, a relentless crimson wave, crashed against the borders of East Prussia. Romania, Bulgaria, and Finland had all abandoned the Axis cause. Soviet tanks now stood at the very gates of Germany itself. In the West, the Allies had swept across France and Belgium, liberating Paris and Brussels, and were now massing for the final invasion of the German heartland. The Third Reich was in its death rattle, losing ground, losing hope, losing everything. In such a desperate situation, any long-term grandiose project became meaningless. Weapons were needed here and now, not in a year, not in two. Finally, in November, reality prevailed. Hitler signed the order. All work on Project Maus was to cease immediately. Every last rivet, every skilled worker, every factory floor was to be dedicated to the frantic production of conventional tanks and anti-tank gun. The two prototypes that had been completed were left to rust at the Kummersdorf proving grounds, not far from Berlin. There were vague, desperate plans to use them in the final defense of the capital, should the unthinkable happen. But even in the most fevered planning of the German High Command, no one could find a truly worthy role for these steel leviathans. The dream of an invincible colossus had shattered against the brutal reality of war and the simple laws of common sense. So they sat, these two, complete, its massive turret and cannon fully installed. The second remained a headless beast, its turret never mounted before the project was canceled. A small skeleton crew of engineers and mechanics continued to conduct tests, a futile exercise they all knew no longer had any practical meaning. They drove the tanks around the muddy grounds, measuring their meager performance, testing their complex systems. On one occasion, they even conducted a live firing of the main gun. The 128mm cannon, a weapon of terrifying power, demonstrated magnificent accuracy and force. It was a glimpse of what might have been, a final, deafening report from a ghost of steel, a testament not to victory, but to the profound and tragic weight of delusion. But what is the point of a truly deadly weapon if its carrier can barely crawl? The winter of 1944 to 45 was a season of brutal reckoning. Across the frozen plains of Poland, Soviet armies were advancing with breathtaking speed, driving relentlessly towards the very heart of Germany. The Wehrmacht was collapsing, surrendering one defensive line after another in a desperate, chaotic retreat. To the west, Anglo-American forces were bogged down in the Ardennes, grappling with the last great German offensive of the war. The Reich, Berlin was bracing for a siege. In January, the Red Army unleashed the Vistula-Oder offensive. In the space of a few weeks, they covered a distance of nearly 500 kilometers, a blitzkrieg in reverse that left German High Command utterly paralyzed. The pace was so ferocious that there was simply no time to organize new lines of defense. Day and night, the T-34s and the mighty IS-2s rumbled onward, bypassing pockets of resistance, their sole objective fixed on the horizon. By the end of the month, the forward Soviet units were a mere 70 kilometers from Berlin itself. And suddenly, the Kummersdorf proving ground, the secret heart of German weapons development, found itself directly in the path of the storm. A frantic order was issued from the highest echelons of command: evacuate all valuable equipment and destroy what cannot be moved. The engineers received their final, grim directive concerning the two Maus prototypes. Under no circumstances could these unique machines be allowed to fall into enemy hands. Soviet intelligence was already aware of the existence of these super-heavy tanks and was hungry to capture one for study. The Germans knew just how valuable these prototypes were, not as weapons of war, but as repositories of advanced technology and radical engineering solutions. Demolition crews set to work, laying charges inside both steel titans. The first Maus, the one fitted with a turret, was destroyed completely. A cataclysmic explosion tore its hull apart, ripping the massive turret from its ring, a grotesque pyre of twisted, scorched metal. But with the second prototype, there was a problem. Explosives were running low. The demolition charge was weaker than required. The blast damaged the running gear and the engine, but the colossal hull remained largely intact. There was no time to lay a second charge. Soviet reconnaissance patrols were already being spotted in the forests surrounding the facility. On the 21st of April, 1945, Soviet sapper units cautiously entered the Kummersdorf testing grounds. The Germans had fled, abandoning everything. Amidst the rubble of bombed-out buildings and the craters that pockmarked the landscape, the soldiers discovered the remains of two gigantic tanks. The sapper battalion's commander was stunned by their sheer scale. Even in their ruined state, these steel monsters projected an aura of terrifying power. His men clambered all over them, marveling at the impossible thickness of the armor, the sheer audacity of their design. Military intelligence officers immediately relayed the discovery to Moscow. The order that came back was swift and unambiguous. Evacuate both tanks at any cost. Soviet command understood perfectly that German engineers had not built these giants for nothing. They were keys to a future of warfare, and now that future belonged to the victors. The resources expended were staggering. To study the construction of these machines could unlock invaluable secrets of German technology, in tank design, in metallurgy, in the very heart of their engine-building philosophy. Besides, these were the only tanks of their class in the entire world. The trophy was truly unique. Its journey would become an engineering epic. Soviet specialists first had to assemble one more or less complete tank from the mangled wreckage of two prototypes. From the destroyed first Maus, they salvaged the intact turret and, with immense effort, hoisted it onto the hull of the second, which had suffered less catastrophic damage. The colossal tracks were replaced, the engines repaired as much as was possible in field conditions. What emerged was a hybrid, a chimera born from two ruined machines. But it represented a relatively complete specimen of German engineering ambition. Transporting it required a search for the most powerful railway platform in existence. They found it, the very same specialized German flat car with 24 axles, designed specifically for the Maus. Across the war-ravaged railways of Europe, the convoy crawled at a walking pace. Bridges were avoided entirely. Routes were painstakingly chosen to cross only the most robust river crossings. The path from Germany to the Kubinka Proving Grounds near Moscow, a top-secret facility for testing captured equipment, took nearly 2 months. The train moved only during the day, under heavy guard, with constant stops to inspect the tracks and the groaning platform beneath its 188-ton burden. That summer, the Maus finally arrived at Kubinka. Soviet engineers descended upon it. They meticulously measured the Titan, photographing every detail, disassembling every accessible component and assembly. They conducted several mobility trials, confirming that the German calculations had been entirely correct. The tank could indeed reach a speed of around 20 kilometers per hour, and its fuel consumption was, as expected, astronomical. Then came the trial of its armor. They turned captured German anti-tank guns upon it, firing round after round at its monolithic hide. The shells simply bounced off, sparking against the steel without causing any meaningful harm. It became clear why Hitler had placed such faith in this project. But in the end, Soviet designers reached the very same conclusions as their German counterparts. Super heavy tanks were a dead end. Their low speed, their enormous fuel demands, the logistical nightmare of transport and maintenance, all of it rendered such machines utterly impractical for the fluid reality of modern warfare. The Soviet Union was, at that time, developing its own heavy tanks. But even the most massive, the IS-3, weighed a mere 45 tons, more than 4 times lighter than the Maus. Soviet tank design had wisely chosen a different path, one dedicated to creating balanced machines, an optimal ratio of protection, firepower, and mobility. For several years, the giant tank stood silent on the testing grounds, a monument to the insane ambitions of a defeated Germany. Occasionally, it was shown to military delegations from friendly nations, presented as a stark example of what not to do in armored vehicle design. Foreign engineers would walk around the Maus, shaking their heads in disbelief, photographing the steel curiosity that represented the thin, perilous line between strategic genius and pure folly. It was a machine that commanded, from all sides, a deeply conflicted response. There was admiration, of course, for the sheer mastery of its German constructors. And then, a profound sense of disbelief at the absurdity of the entire concept. By the early 1950s, the tank had definitively become a museum piece. Its engine, long since seized, would never roar to life again. The rubber elements of its colossal tracks had dried and cracked with age, and from within its cavernous hull emanated the ghosts of machine oil and slow, creeping rust. The Maus was moved to its final resting place in the Kubinka Tank Museum, where it assumed a place of grim honor among the other captured titans of the German war machine. Beside it stood the Tigers, the Panthers, the Ferdinands, all the armor that once seemed invincible, yet had ultimately lost the war. Of all these steel beasts, it was the Maus that held the visitor's gaze the longest. Its dimensions defied imagination, even decades after the conflict that spawned it had ended. People would approach its tracks, which towered over a grown man, and run their hands across armor plate as thick as a palm. They would press their faces to the viewing slits, trying to pierce the darkness within. The museum guides would tell the story of this monster's creation, explaining why it never once saw combat. They used the Maus as the ultimate object lesson in how technical power, devoid of strategic sense, inevitably becomes nothing more than a useless pile of metal. For subsequent generations of engineers, the Maus became a textbook case in design failure. Its construction was filled with fascinating, forward-thinking solutions: a revolutionary electric transmission system, a hermetically sealed hull for deep-water fording, and of course, its devastatingly powerful armament. But all these achievements were rendered meaningless by a single, fundamental miscalculation. The tank was simply too heavy for its time. The technologies of the 1940s could not produce an engine with sufficient power that also had acceptable dimensions and fuel consumption. The German designers had tried to cheat physics, but the laws of nature proved implacable. The story of the Maus became a cautionary tale whispered among tank builders across the world. When the Americans developed their own heavy tank, the M103, in the 1960s, and as Soviet engineers worked on their formidable Object 279, both sides remembered the lesson of the German giant. Both of those later projects remained largely on paper, or as single experimental prototypes. The future of armored warfare was moving in a different direction, towards the medium and main battle tanks, weighing a more practical 40 to 50 tons that could balance protection, firepower, and, most critically, mobility. The sole surviving Maus still stands in that museum, a permanent reminder of how grandiose plans shatter against the unforgiving wall of reality. It is the heaviest tank in human history, a machine into which the immense resources of a dying Third Reich were poured. It was a marvel of German engineering and, simultaneously, a symbol of profound strategic blindness that never fired a single shot in anger. Its cannons remained silent. Its tracks never crushed an enemy trench. Its armor never deflected a shell in the crucible of real combat. 200 tons of steel became an impressive exhibit, proving a simple, eternal truth. In war, victory is not won by the heaviest armor or the largest gun, but by the side that understands the brutal calculus of the possible. It was never about creating the largest weapon, but the most lethally efficient. In the twilight of the Third Reich, as grand armies crumbled, the minds of its engineers turned inward, toward projects of a different, more terrible nature. They sought not a titan of steel, but a whisper of death. A surgical strike born from a project that bordered on pure insanity. The cost, of course, was never measured in mere currency, but in lives sacrificed to a fever dream of technological supremacy. In the end, the true measure of such an invention is not its power, but the chilling question it leaves behind. A testament not to genius, but to the terrifying depths of human ambition when divorced from its humanity.